Welcome to ClickMyProject.com. The title of the project is Epileptic Seizure Detection by Cascading Isolation, Forest-Based Anomaly Screening and Easy Ensemble. And the abstract of the project is an encephalogram is generally used ancillary test for the diagnosis of epilepsy. The EEG signal contains information about brain electrical activity. Neurologists employ direct visual inspections to identify epileptic from abnormalities, and this technique can be time consuming, which provide variable results secondary to reader expertise level, and it's limited to identify the abnormalities. Prediction of the disease can help the patient prevent the onset of seizures with the help of appropriate medications. Since the traditional method of studying EEG are prone to misdiagnosis, deep learning like long short-term memory neural network and artificial neural network deep learning algorithms are applied and provide a more accurate diagnosis. In this process, we aim to survey models to better describe methodologies for a high precision model to predict epilepsy in patients. So the deep learning algorithms are used to predict the normal and seizure classes and generate the result in the form of matrices like accuracy, precision, recall and FN score. And the flow diagram of the project is, first we need to start the program and select the brain injury EEG dataset, and after that we are going to view the sample dataset in our console working directory. Then it will move into data pre-processing. In data pre-processing we are going to clean the dataset, like we are going to check if it is contains any null values. We need to check the null values and replace the null values in the mean value of our dataset. After that it will move into data selection like model selection. In that we are going to split our dataset into training dataset and testing dataset. Then it will move into classification. In classification we are going to apply two different types of deep learning algorithm like long short-term memory neural network and artificial neural network. The both neural networks are used to classify our dataset and predict the result in the form of matrices like accuracy, precision, recall and FN measure. I was successfully executed my program in Anaconda Navigator Spider IDE. So this is the sample data set of brain injury EEG dataset. It's like a seizure prediction dataset. So after that I have to check the information about the dataset. In our dataset contains 180 columns. So in 179 columns are like a integer data type, and your final column will be the object data type. So after that I have to check the description about the dataset. So in that I have to check the count value, mean value, standard value, minimum to maximum value for every columns contains in our dataset. So after that I have to apply it into pre-processing. In pre-processing I have to check the null values. If it is null values contains in our dataset, it will show true, otherwise it will show false. So there is no missing values or null values in our dataset, so it will show the false. So these are all the classes based on the EEG results. So in that these classes are defined as the, so these are all of our classes of our dataset. So for label 1 is recording of seizure activity, and label 2 is they recorded the ECG from the area where the tumor was located, and the label 3 is yes, they identify where the region of the tumor was in the brain and recording the EEG activity from the healthy brain area. And the label 4 is eye closed, means when they were recording the EEG signal the patient had their eyes closed. And fifth label is eye open, means when they were recording the EEG signal of the brain the patient had their eyes open. So these are all the classes we are going to predict from our dataset. So in first I have to apply the long short-term memory neural network algorithm. So in that I have to apply the 13 different training epochs. So the LSTM algorithm will train the data set based on the 5 different classes, and these are all the accuracy and validation accuracy, loss and validation losses, and these are the plots like a history of our long short-term memory neural network algorithm. So after that I have to converted into binary classification. So in that I have to calculate the accuracy result of LSTM algorithm is 97%. So these are all the classification result of long short memory neural network algorithm. In that we are going to predict the normal and seizure classes. For the precision of normal and seizure classes is, and recall for normal and seizure classes, and F1 score for normal and seizure classes. So in that, precision means number of correct prediction and recall means number of correct instance of prediction, and F1 score means to measure the test accuracy. So after that we have to check the exception of our LSTM algorithms result. So that we have to find the confusion matrix. So this is the confusion matrix for normal and seizure classes. So this is number of correct classification for normal, and this is number of correct classification for seizure, and this is misclassified result for LSTM algorithm. So after that I have to apply the artificial neural network algorithm. In that I have to apply the 80 different training epochs, so that the artificial neural network for 5 classes it will provide only these results. So these are all the visualizations of accuracy, loss, validation accuracy, and validation losses. So after that I have to convert it into binary classification. In binary classification the ANL accuracy will be 94%, and these are all the classification results for normal and seizure classes for artificial neural network algorithm, and this is the confusion matrix for artificial neural network algorithm, and these are all the variable results that we are using in our program.